Hello students, welcome to the lecture series on the subject DWM, that is data warehousing and mining. In the previous video we have seen what is Bayes theorem and how we can use this Bayes theorem for Bayesian classifier. Today we will look at one example how we can use this Bayes classifier to find out the class. Okay, this is our training data set. Okay. So we have converted this training data set into an Excel file like this. Only difference is for the age. Okay, so here age is less than 30 or maybe 31 to 40 and greater than 40. Here for less than 30 we have used the term or value youth. Between 31 to 40 we have used middle age, and greater than 40 here we have used as a senior. Remaining data set is as it is. Okay, so here we have two class. If you look at this data set, we have two class: Bayes computer, either it will be yes or no, and this is our new data set. Okay, so for example our new tuple is having age is equal to less than 30, that is youth, income is equal to medium, student is equal to yes, and credit rating is equal to fair. Okay, so from this data, okay, or from this tuple we have to find out to which class this particular tuple will belong. Okay, whether it belong to Bayes computer yes, that is C1, or whether it belong to Bayes computer no, that is C2. Okay, so we have to use this Bayes classifier for this purpose. Okay, so here there is a assumption class conditional independence. Okay, so that we have to first look at. Okay, means what? म्हणजेच काय बेसिकली तर हा जो डिसिजन आहे बायस कम्प्युटर यस नो, ओके, तो या कुठच्याही ज्या ॲट्रिब्यूट्स आहेत त्या एकमेकांची इंडिपेंडंट आहेत. ओके, म्हणजे एज इज इंडिपेंडंट ऑफ इन्कम, इन्कम इज इंडिपेंडंट ऑफ स्टुडंट, अँड स्टुडंट इज इंडिपेंडंट ऑफ क्रेडिट रेटिंग. म्हणजे एज चा इफेक्ट इन्कमवर नाही आहे, इन्कमचा इफेक्ट स्टुडंटवर नाही आहे, आणि स्टुडंटचा इफेक्ट क्रेडिट रेटिंग, आणि ह्यांचा इफेक्ट जो आहे तो बायस कम्प्युटरवर नाही आहे. ओके, नाही आहे इन द सेन्स एजचा इफेक्ट जो बायस कम्प्युटरवर आहे, ओके, तो इंडिपेंडंट आहे इन्कमचा इफेक्ट बायस कम्प्युटरवर. ओके, सो हियर वी हॅव टू यूज Bayes classification algorithm. Okay, so as we have seen how we are going to use this. Okay, for that we need to calculate two probabilities. Okay, that is probability of particular class, that is Bayes computer yes and Bayes computer no, because we have two such classes and we have to calculate these conditional probabilities. Okay, probability of x provided that particular x belong to class Ci, that is yes or no. Here x is having attributes. In our case x is composed of age, income, student, and credit rating. Okay, now we will let us do the calculation. Okay, so this is our probability, basic probability, prior probability. Probability of Bayes computer is equal to yes is equal to 9/14. Okay, so from where we get this? Yes. Okay, so how many such tuples are there? Total there are 14 tuples. Out of these 14 tuples, total 9 tuples are there which are saying Bayes computer is equal to yes. That's why 9/14, that is 0.643. Okay, so this is the probability that a particular customer will buy a computer. Okay, and this is the probability, okay, that that particular customer will not buy a computer, that is Bayes computer is equal to no. How many such tuples are there in our training data set? Let us look at this. Bayes computer is equal to no, so total there are 5 such tuples. That's why 5/14. Okay, so this is the probability of each and every class, that is yes, probability of yes and probability of no. We have done the calculation of first part or this part. If you look at the example, this part we have done. P of C1, that is Bayes computer is equal to yes, P of C2, that is Bayes computer is equal to no. Okay, now we have to calculate this conditional probability. Okay, so for that we have to use this particular formula. Okay, because all our variables or features, or we can say attributes, are categorical. Now let us do the calculation. Compute P of X provided we know the CI for each class. Okay, so here our values are age less than 30. Okay, so let us calculate age less than 30 for yes and no. Okay, probability of age is equal to less than 30 provided that we know the result or class Bayes computer is equal to yes. Okay, so first we'll look at the calculation for class yes. Okay, so let us look at this thing. We have to choose the Bayes computer is equal to yes. Okay, so such there are 9 tuples, and now we have to find out of these 9 tuples how many tuples are there where age is less than 30. Okay, that is youth. Okay, so let us look at this youth. Okay, so how many such tuples are there? Only 2 tuples. Only 2 tuples are there, and total Bayes computer is equal to yes are 9. Okay, so that's why 2 by 9, that is 0.222. Okay, so that's how we do the calculation. Okay, now let us look at the income is equal to medium, Bayes computer is equal to yes, income, that is second attribute. Okay, so first we have to uncheck this. Income is equal to medium. Income is equal to medium. Okay, so how many such attributes? 1, 2, 3, 4. Okay, that's why 4. And why, from where this 9 comes? Okay, these are the total number of tuples in which Bayes computer is equal to yes. Similarly, student is equal to yes, Bayes computer is equal to yes. That is third attribute over this student. Okay, so let us do the calculation or find out. Bayes computer is equal to, student is equal to yes, 1, 2, 3, 4, 5, 6. So 6 out of 9. Okay, tuples where student is equal to yes. Okay, so this is how we go on calculating for for each and every attribute. Okay, so like this here, for age less than 30, what is the probability that Bayes computer is equal to yes? And for age less than 30, what is the probability that Bayes computer is equal to no? Okay, so that's what we have done here. Age less than 30, Bayes computer is equal to yes. What is the probability? Age less than 30, Bayes computer is equal to no. What is the probability? Similarly, we have find out the probability for income is equal to medium. Bayes computer is equal to yes. Bayes computer is equal to no. Okay, and so on. Okay, so these are the different probabilities. Okay, so now X is composed of these 4 attributes: age less than 30, income medium, student yes, and credit rating. Now we have to calculate this probability, conditional probability. Okay, so this will be the conditional probability of X where Bayes computer is equal to yes. This is basically a product of this age is less than 30, this one, that is 0.222. Then for this income is equal to medium, Bayes computer is equal to yes, that 0.444. Then this one, by student is equal to yes, Bayes computer is equal to yes, that is 0.667, and credit rating fair, Bayes computer is equal to yes, 0.6. Okay, so this is a probability, conditional probability, where we know that Bayes computer is equal to yes, that is 0.444, and this is a probability, conditional probability for Bayes computer is equal to no, that is 0.019. Okay, now we have to multiply these particular probabilities with prior probability, that is probability of yes and probability of no. Okay, so this is our final calculation. Probability of X, where we know that Bayes computer is equal to yes, into probability of Bayes computer is equal to yes. Okay, so that is 0.044 into 0.643. Okay, so the answer will be 0.028. Okay, so this is the total probability that for this particular X, buys, that particular customer will buy the computer. And this is the similarly will calculate this conditional probability of X provided that it will not buy computer, and into probability of Bayes computer is equal to no, that is 0.007. From where we get this? This is the multiplication or product of 0.019 into 0.357. Okay, then we compare these two. Okay, this is for yes 0.028 and for no 0.007. Okay, so when we compare this is bigger, 0.028. This is a higher probability than no. Okay, so for this particular tuple x, where age is less than 30, income is medium, student is yes, and credit rating is fair, our class is yes. Means what? That particular customer will buy a computer. Okay, so this is how we do the calculation. Again, quick revision how we do the calculation if there is a question on this particular example. Okay, so how we will proceed? We will first calculate the probabilities for all the classes. In our case, we have find out the probabilities of yes and probability of no for total data set. Okay, so this is what we have done. Okay, then we have to find out the probability for conditional probability for each and every attribute on that particular value only. That is, here we are interested in the attribute where age is less than 30. We are not at all interested in the probabilities where age is greater than 40 or age is between 30 to 40. That's why this is very simple. Calculation is very simple. Okay, so now there is an issue. Okay, that is zero probability problem. Okay, in Naive-Bayesian prediction requires each conditional probability to be non-zero. Okay, so what if the probability is 0? Okay, so in that case the whole product will become 0 and we will not get the accurate answer. Okay, so suppose there is a income field, okay, where low income is there. There are suppose 1000 टपल्स, 1000 टपल्स आहेत, त्याच्यापैकी लो इन्कम वाली टपल्स किती आहेत? 0 आहेत. मीडियम इन्कम वाली 990 990 and income high are 10 tuples. Okay, so in that case if there is a customer with low income, then total probability will be directly 0 because these terms will become 0 and total probability will 0 and we will not get the proper output. Okay, so for that purpose we will use a Laplacian correction. Okay, so what we do basically, we add one such tuple in each case. Okay, so that is probability of income is equal to low. Okay, so this is the probability, this one. Okay, so actually low income there was no tuple, we have added one such tuple. Okay, and for each class for each income, low, medium, high, we have added one such tuple. Okay, so total there are 3 tuples. Okay, so the total probability probability of income is equal to low will be 1 upon 1003. Same case for income is equal to medium, 990 which was original, we have added one such row having income is equal to medium, so 991 divided by 1003. Same case for probability of high. Okay, 11 divided by 1003. Okay, so this is the Laplacian correction. Why we are requiring this? In order to avoid the zero probability problem. Okay, now we look at the strength and weaknesses of this Naive-Bayesian classifier. Okay, so strength are, it is easy to implement. Okay, obviously we have seen already where there are very less calculation and simple calculation. Okay, and good results obtained in most of the cases. Okay, so these are the strength. And what are the weaknesses? Assumption, attributes conditional independence. Okay, therefore loss of accuracy. Okay, so this Naive-Bayesian classifier is totally dependent on conditional independence, attributes conditional independence. Okay, but in real world there may be some form of dependence. Okay, so there is some form of loss of accuracy. Okay, but for practical purpose we have done this assumption. Practically dependencies exist among variables. For example, patients, profile, age, family history, etc. If we are talking about symptoms, fever, cough, then diseases, lung cancer, etc. Okay, so dependencies among these cannot be modeled by this Naive-Bayes classifier. Okay, so there may be interdependency among different attributes which comprises a particular tuple. Okay, so now how to deal with this dependencies. Okay, so we can use Bayesian belief network. Okay, but we are not going to study this for this subject DWM. Okay, so that's it for this particular video. In the next video we will talk about how we can do the model evaluation and selection. Okay, how can we measure the accuracy and how we can compare the two models, accuracy of two models. Thank you.